Good morning, everyone. Today we will be discussing about the salinity of the ocean water. Salinity can be defined as the ratio between the weight of the dissolved materials and the weight of the sample seawater. So, generally we can define salinity as it is the total amount of solid materials in grams contained in 1 kilogram of seawater. The salinity of oceans is generally expressed in the way of part per thousand. Let's look into what the seawater is mainly composed of. The seawater generally contains a complex solution of several mineral substances in dilute form because we know that water is an active solvent. The total amount of salt in the seawater gradually increases because it is generally brought from the land every year. It is estimated that the total amount of salt dissolved in our seawater weighs about 4,800 million tons. Gitama, during his Challenger expedition, has reported the existence of 47 types of salt in our seawater. Among these, some of the important ones we all know that is our sodium chloride, or we simply call them as common salt. Besides, we can see sodium sulfate, magnesium chloride, potassium, bromide and many more. Besides these salts, we can also find the traces of silver, gold and radium in minute proportion in our seawater. Generally, this proportion or the composition always varies from one place to another. Let's look which is the major source of our ocean salinity. Basically, the major source of our ocean salinity is our land itself. The river will bring enormous amount of salt in solution form from the continental areas. But there is a lot of variation in the composition of our sea salt and riverine salt. If you look at the case of our riverine salt, 60% of the salt is being constituted by calcium sulfate. At the same time, we all know that sodium chloride mainly dominates in the salinity of oceans. At the same time, the river water only contains about 2% of the sodium chloride. So what may be the reason? The major reason or what they are thinking is that the major portion of the calcium brought by the rivers into the ocean is being consumed by the marine organisms. Secondly, the salt brought by the rivers is generally bit modified in our oceans. Volcanic ashes also provide some amount of salt to our oceans. Let's look into what are the factors that influence the salinity of the ocean water. The factors that affect the amount of salt in our seawater differs always from one ocean and seas, and this we call them as controlling factors of ocean salinity. So which are the major controlling factors of our ocean salinity? Evaporation. There is a direct relationship between the rate of evaporation and salinity. That is, if the evaporation is very high, then the salinity will be automatically higher and vice versa. When the evaporation takes place due to high temperature with low humidity, there would be much concentration of salt. If you take the case of our higher latitudes like in our tropics, salinity is generally higher. The second one is that of our precipitation. Here, there lies an inverse relationship between the precipitation and salinity. That is, if the precipitation is high, the salinity will be comparatively low and vice versa. That is why the equatorial region have low salinity. Even though the region is receiving high temperature and evaporation, the region generally have low salinity due to more amount of conventional rainfall received in the region when compared to subtropical high pressure belt. The third controlling factor is the influx of river water. We already discussed that river is the major source of ocean salinity. Even though the rivers will bring salt from land to ocean, big rivers will pour immense volume of water into the oceans, and thus the salinity is reduced at their mouth. You can find low salinity near the mouth of River Ganga, River Congo, Amazon, Ural, Volga, and many such vast mighty river mouths. Atmospheric pressure and wind direction is another controlling factor of ocean salinity. Anticyclonic condition with a stable air and high temperature increases the salinity of ocean water. Winds also help in the redistribution of salinity of water as the winds drive away the saline water to less saline areas, resulting into a decrease of salinity in the former area and an increase of salinity in the latter. Ocean currents affect the distribution of salinity by mixing the seawater. For example, consider the case of equatorial warm current. The equatorial warm current drive salt away from the western coastal areas of the continents and accumulate them along the eastern coastal areas. In northern hemisphere always records the maximum salinity in the month of June and minimum salinity in the month of December. So we can comprise the totally comprises of the following controlling factors of ocean salinity, that generally the evaporation of seawater increases the salinity. At the same time, if there is high evaporation too, the precipitation through the form of rain or snow will reduce the salinity of ocean water. Apart from that, the influx of river water or the river runoff reduces the salinity at the mouth. If the water is flowing from the ground to the ocean, also reduces the salinity. At the same time, if the seawater is getting freezed, it will increases the salinity. Distribution of salinity. The average salinity of the ocean and sea we have already discussed is about 35 parts per thousand. But this is spatially and temporarily varying in different oceans, seas and lakes. We generally studied the spatial distribution of salinity of ocean water in two ways: the horizontal distribution of ocean salinity and through the vertical distribution of salinity. So, the horizontal distribution of ocean salinity is studied in relation to latitudes. At the same time, we will be also considering the regional distribution. The latitudinal distribution, on an average, if you look, the salinity decreases from equator towards the poles. The highest salinity is seldom recorded near the equator, even though this region records high temperature and high evaporation. But it is the factor that the rainfall due to the conventional precipitation reduces the relative proportion of salt. Thus, the equator accounts only 35 parts per thousand of salinity. The highest salinity is observed between 20 degree to 40 degree north, where it is 36 parts per thousand. This we have already discussed, that the subtropical region generally will be having higher salinity because of high evaporation and reduced precipitation. The zone between 40 degree to 60 degree latitudes in both the hemispheres records low salinity, while the northern hemisphere accounts for 31 parts per thousand and southern hemisphere accounts for 33 parts per thousand of ocean salinity. The salinity further decreases polewards because of the influx of melted water from the glaciers. Thus, on the basis of latitudinal distribution of salinity, we can identify 4 zones of ocean salinity. The equatorial zone is the zone 1 of relatively low salinity due to excessive rainfall. The second zone is the tropical zone of maximum salinity due to low rainfall and high evaporation. The third zone is the temperate zone of low salinity, and zone 4 is the subpolar and the polar zone of minimum salinity due to the melted water from the glaciers. Regional distribution of surface salinity of oceans and seas is also described in 2 ways. One is the distribution of salinity of the individual oceans, and the other is the salinity zones of all oceans together. Jerkins has divided the oceans on the basis of salinity variations into 3 categories. The category 1 is the regions or the seas having salinity above normal. You can take the case of Red Sea, Persian Gulf, Mediterranean Sea under the regions or the seas having salinity above normal. Our normal salinity we have already discussed is about 35 part per 1000. So these seas will be having a salinity of above 35 part per 1000. The category 2 is the sea having the normal salinity. You can take the cases of Caribbean Sea, Gulf of Mexico, Gulf of California under this category. Category 3 is the seas having salinity below normal. Arctic Ocean, China Sea, Japan Sea, Bering Sea, Andaman Sea, English Channel are some of the seas having salinity slightly less than the below normal level. At the same time, you can experience a very low salinity in the Baltic Sea and the Hudson Bay. The amount of salt in the inland sea depends upon 4 major factors: the rate of evaporation, temperature, influx of rivers, and presence or absence of outlets. Salinity is generally reduced because, especially in those areas where the river comes out of a lake or an inland sea. Similarly, pouring of large quantity of fresh water by the rivers into the lakes also lowers salinity. You can find low salinity in the northern part of Caspian Sea because of addition of enormous volume of water brought by river Volga and Ural. At the same time, we can experience high salinity in Great Salt Lake in USA and Dead Sea. Moving to the vertical distribution of the ocean salinity, you can find no definite trend of distribution of salinity with depth, because we can experience both the trend of increase and decrease of salinity with increasing depth. Let's look into some of the salient features or the characteristic of vertical distribution of ocean salinity. The salinity generally increases with increasing depth in higher latitudes. Thus, there is a positive relationship between the amount of salinity and the depth because of denser water below. This trend of increase of salinity with increasing depth is generally confined to 200 fathom in middle latitude. Beyond this 200 fathom, you can observe a decrease in salinity with increasing depth. Salinity can be generally found lower at the surface of the equator because of heavy rainfall. But higher salinity is generally noted below the water surface. It again becomes low at the bottom. The maximum salinity on a general can be found in the upper layers of ocean water. Thereafter, the salinity decreases with increasing depth. Thus, the upper zone of maximum salinity and the lower zone of minimum salinity is separated by a transitional zone, and this zone is called as thermocline zone. So, this is all about the ocean salinity, its major features and distribution. I hope you enjoyed the session, and thank you and have a nice learning. For any further clarifications, you can visit my Edmodo with code QN5QR4.